Good day, everyone. Welcome to episode 010 of Code While. In this episode, I'll talk a little bit about copying functions, but adjusting them to have different scopes of identifiers. There's a QR code at the top right of this web page here. If you scan it and follow the resulting link, you'll reach the same web page here, where you can follow along with the code if you like. All right, a little history here. Another way to manipulate scopes is with the with keyword in early JavaScript versions. Here's an example here, an anonymous function. I'm calling it. It's got a couple of variables, return value and scope. Scope is an object with the property foo with value 42. And then I use the with keyword, and I specify scope as the subject, and then the statement to be executed within the with body is to assign the value of foo to the variable return value. But where does foo come from? Foo isn't a variable up here. It comes from this scope object, and that's how with performs. And so we see that it works out, and the property's value 42 becomes the return value and gets returned here. But some people do not like with, and some people invented strict mode in newer JavaScript implementations. So here's how to use strict mode in this context here, specifying a string that has the words use space strict before anything else, and that doesn't permit the with keyword to work anymore, as this error down here shows. Strict mode code may not include a with statement. And I think some of the rationale had to do with performance concerns. Some of the rationale had to do with programmers making mistakes using the with keyword, it being too error prone. But it can still be useful. Now, there's another approach to manipulating scopes, and that's with the function constructor. So here's the function constructor here. It can be called with or without the new keyword. It'll still give you a useful function. Here I'm making one, and I'm specifying a function body of return type of anonymous, whatever that means. So I'm going to create that function. I got an OK, so no error was thrown. I got function via constructor. I'll take a look at the string representation of that resulting function. And it's got a name called anonymous. It's got no arguments here. And it's got the function body that I specified, return type of anonymous. Okay. But despite the name being present there, anonymous, that identifier doesn't enter the scope of the function body. So here I'm going to call it, and we would expect that since we're inside this function, the type of anonymous, well, that's right here. It should be a function. The result should be function. But instead, we get undefined. So that's a little quirk to be aware of. This anonymous doesn't have the same meaning. If you were to copy and paste this function, you'd get a function called anonymous. And if you called it, the result would be function. But not using the function constructor, as has happened here. All right, and here's another example. This time I'm going to create some named arguments for the function. Here they are here. The names are 1 and 2, and then the final argument to the function constructor is the function body. You can put as many of these as you like before the function body. This time I've changed the function body to return the type of 2, whatever that is. Once again, we get a anonymous function, and this time we see the 2 named arguments inside here. Now if I try to call that and I pass it 2 arguments, one is a string called answer and then the number 42, we should expect this 42 will be the 2 argument, and the return statement with the type of 2, that should return a number. And that's what it returns, a number. So that's how the function constructor works. And it's going to be the tricky part of this episode here. So here is today's special. I've got an anonymous function here, and down at the bottom here, it's inside an expression. I'm calling it, and I'm assigning the result to EP for episode 010. Inside there's a variable called bar. I'm assigning it the value of 42, and all this anonymous function is going to do is return an object with two properties, rescope and scope check. So the first function here, rescope, takes a function argument and a new scope argument, but there are other ways to invoke it as well, which I'll demonstrate a little later on. And it has a bunch of variables: builder parts, constructor parts, func string, I, key, new func, noted, and object keys. Then I do a lot of checking here to throw errors in case the invocation isn't quite right, and also to canonicalize the invocation. So in some of these cases here, you'll see I'm calling the same function again and returning its result, but I've maybe switched a few things around depending on how the original invocation went. I might move something like the this to become the first argument. We'll see about that later on. Finally, after getting past all of that error checking and canonicalization, I check if the type of the first argument, func, is not equal to a function. I'll throw an error about that. Then the builder parts variable is initialized to an empty array, same with constructor parts. And then I take the caller's func, take the string representation of it, and store that to func string. Now, the new scope is an optional argument here. It can either be omitted, or undefined, or null, or an object. So if the argument's length is 2, it's been specified, and if the type of the new scope argument is not undefined, and if it's not null, then all of this body of this if here will be executed, but not if it's not specified. So the first thing I'll do is I check if the new scope is not equal to an object. I throw an error if that's the case. Now here I'm making an object called noted, and I'm going to use it as a sentinel value. There's no way that the caller can access this noted object, so it's handy to be able to use it as a sentinel value in some of the accounting that happens here. The next thing I'm going to do is I'm going to scan the properties of the new scope object that was specified. And there are two techniques for doing it here, and it doesn't matter which order they're performed in, so these two could be swapped around. But I want to avoid double accounting here, so every property that's discovered in the new scope object should only be accounted for once. And the way I do that is by using the noted object here. So the first thing I'm going to do is I'm going to check if it's a newer JavaScript implementation that has object.keys function, and if that's available, I'll use it on the new scope to get a list of the keys and store that in object keys. Then I'll iterate over those keys. I'll fetch the key for the current iteration, and I'll check that noted object for a property with the key as its name, and I'll check for equivalence with the noted object itself. That's the sentinel value check. And if it's found, I'll skip that item because it's already been accounted for, and I'll carry on with the loop. And it's the same thing down here in the next technique. Otherwise, if it's a property that hasn't been noted, then I'm going to take the value of that property from the new scope object and push that onto the builder parts array. Then I'm going to take the property name, the key, and push that onto the constructor parts array, and then account for it so that it doesn't get duplicated in the next technique. And the next technique uses for key in new scope to get the property names, and it does all the rest is the same as the business in the previous technique. So by the end of this, we've collected, hopefully, all of the properties in the new scope object, both their values and their property names. So then there's going to be another final piece in the constructor parts array, which has all of the keys, property names in it. I'm going to push another piece, and that's going to be a string. That's going to be the function body for an anonymous function. And all it's going to do is return a copy of the caller's function via the string representation. And there's a little semicolon just to be nice. So that's going to be in the constructor parts array. It's going to have one more element than the builder parts array. So what do I do here? I call the function constructor, but I use the apply technique. I pass it no this, and I pass it the constructor parts array for what gets applied to the function constructor. It's going to have 0 or more of the properties from the new scope as the first elements, and then followed by the function body. So that's going to return a function, an anonymous function, and that'll be assigned to this builder variable. Next, I'm going to take the builder parts, which are the values for those properties in new scope, and those are in an array, and those will be passed as arguments to that anonymous function. So then the values are going to be assigned to the property names, and all of those are going to be in scope for the copy of the function. And what's the anonymous function going to return? It's going to return the copied function. I'm going to store that into new func, and then I'm going to return new func. And that's what rescope does. So essentially, it's making a copy of the function's code while adjusting the scope of the identifiers that are available to that copied function. And here's the other function. Here is a scope check. All it does is take code and execute the built-in function eval with that code and return the result. All right, so here's just some evidence that this scope check function has the identifier bar in scope. You'll recall up here we had bar is 42. So this is going to check that the type of bar, well, it should be a number. It's a number. And of course, it also has access to the value. I'm going to just return the value of bar. It's 42. All right. Now I'm going to do some of the error checking for the rescope function. Here I'm passing too many arguments. I get a nice error for that. Here I'm using a non-function this for invoking rescope with no arguments. I get a nice error about that. Non-function this, non-function argument. Well, there's got to be a function somewhere. It must involve a function. Non-function this, non-function first argument, 2 arguments. That's not going to work out. Func must be a function. Okay. Non-function this, function is first argument. This one is starting to look good, but then new scope is a number instead of an object, so that's not quite right. Throw an error about that. All right. Now something more interesting here. I'm going to take the rescope function from ep010 and assign that as a property of the scope check function. This could also be a member of the function.prototype object, and then rescope would become available for all functions. But right now, I'm just going to do it for scope check. So that's done. And here I'm going to try to execute it with a new scope of 42. That doesn't make sense, so I'll get an error about that. And what about with a fresh scope? So here now I'm going to make a copy of scope check, but with an empty new scope. It's not going to have the same identifiers in its scope as the original scope check function. Okay, so I didn't get an error there. That's nice. And the string representations between the original scope check and its copy here, they should be equivalent. And true, they are. But they're not the same function. This is a copy and it's adjusted. It's not the same as the original scope check. So it returns false. The fresh scope that was specified just up here, nothing there, means that the bar variable will not be available within the copied scope check. So scope check 2, I'm going to try to evaluate the type of bar, and it yields undefined, whereas earlier it was a number. Okay, I'm going to make another copy. Scope check 3 will be a copy of scope check. This time I'll specify a new scope with the property baz and value 42. Once again, its string representation is the same as the original scope check function. And once again, it doesn't have access to bar because it's a copy that didn't have bar available. And so bar is undefined. But it does have baz because baz was just specified right here. So I'm going to try to fetch the value of baz. And that yields 42. All right, so that's working. Now, a piece of trivia here. Microsoft Internet Explorer 6 has a quirk. Here I'm going to run the scope check function and evaluate some code. What I'm checking for here is that the function that I'm invoking, ep010.scopecheck3, I'm going to check it for equivalence with whatever the scope check identifier is. Now we might expect if scope check 3 executes as this function here, then scope check should be the identifier for the very function that's being called, but not for Microsoft Internet Explorer 6. Microsoft Internet Explorer 6 checks this and yields false. Many other JavaScript implementations yield true, including this web browser. So I get true. But if we wanted to, if we really wanted to for some unusual reason, we could do something like this. We could call scope check 3, we could make a scope check 4 and assign to that whatever this scope check is referring to. It's something very much like scope check 3, but somehow it's different. So we could take that and assign it, and then if we used that copy, or whatever it is, and invoke that to check for equivalence between that copy and the identifier scope check, this would finally return true here for Microsoft Internet Explorer 6. It also will return true in other JavaScript implementations, like this one. All right. And back to making some invocations of rescope that are a little bit different. I'm going to make scope check 5, calling rescope without a function as it's this, and with a function as the first argument. And that gives another copy of scope check. And this time I'll make scope check 6. It'll be the same thing as before, but with a object as the new scope with property QUX and value 42. And once again, that looks familiar. And it should have access to that QUX. So I'll try that out. And it does, 42. Okay. Well, something to note is that this nice way of manipulating scopes for an adjusted function copy is not a replacement for the with feature because of value copying. In fact, it can happen twice. So here's a return to something like the original code example, but I've changed it a little bit. I've still got the same two variables, but this time the hope is to somehow use rescope to achieve what the with statement achieved before. So I'm using rescope to copy this function down here with scope, and I'm passing it scope, this object here. So within this with scope function, what is it trying to do? It's trying to assign foo to the identifier return value. That's just like the original example, but there are going to be some differences here. This return value here was specified in this scope, but it's not going to refer to this property in the scope. It's going to be a copy of the value from the return value property of this scope. Even though the name's the same, it's a copy of the value. And in fact, the return value property in this scope object, it's going to have a copy of something called return value from out here, which by this point here is just undefined. So we're copying values around twice. Not just once, but twice. Once from here to here, and then once through rescope from this property here into the return value identifier that winds up in the copy of with scope. So anything that happens to return value here can't affect the original nor this intermediary. And what else can I say about that? Objects, including arrays and functions, if they were members of a scope, they are more like pass-by reference or like pointers in other programming languages. So if they become manipulated by a function that has access to them, as long as it's not just assignment, which will replace what the identifier is referring to, if they're manipulated, then those will affect the original object or function or array. But things like strings and numbers, more primitive sort of types, their values are going to be what's available within the rescoped function, so to speak. And the paradigm for those will be that it's safe to consume those items from the scope that's specified for the copied function, but you're not going to get anything useful by assigning to them from a copied function. All right. Well, I hope you learned something there. I hope it was useful to you. And I'll hope that you'll join for another episode of CodeWhile. Have a pleasant day.